Let's have a look at an example that uses a tree diagram to list the possible outcomes in the sample space. So let's read the question. The letters A, B, and C are written on separate cards and placed in a box. 2 cards are drawn out at random without replacement. Now that's very important. That means that we're not putting the card back in the box and then have the possibility of drawing that same card out again. So we're not going to have doubles of anything being drawn, or no chance of doubles, to form a 2-letter string. Okay, so when we talk about a 2-letter string, it's just 2 letters in sequence. Okay, like A, B, or B, C, or AC. Use a tree diagram to list all possible 2-letter strings. And part B, calculate the probability that the last letter is an A. Alright, so let's use the tree diagram. Okay, so I might actually do the tree diagram here, so I've got a little bit more space. Okay, now the first card that we're going to draw, the first card we have a choice of A, B, or C. Okay, they're drawn out at random. There's no bias, equal chance. So 1, 2, 3. Okay. So that's our first stage. Okay, so again, this is a 2-stage, multi-stage experiment. Okay, so we're going to have 2 levels of branches with the tree diagram. Now on the second draw, so this is the first draw. Okay, on the second draw, we're going to have 2 letters left in the box because we've already drawn out a letter. So if we've drawn out the letter A, so which 2 letters have we got left? We've got the letter B and the letter C. If on our first draw we've drawn out a B, okay, that means we've got the letter A left and we've got the letter C left. And on the first draw, if we've drawn out a C, okay, we've got left in the box, we've got the letter A and the letter B. Now we can use our tree diagram to list the sample space. So that's all the possibilities, okay, that are possible with this experiment. Okay, right. So we've got AB, okay, we've got AC, okay, BA, BC, CA, and CB. Okay. Now the question part B says calculate the probability that the last letter is an A. Now these are equally likely. Okay, so there's no bias. So we want the last letter being an A. So there's 2 possibilities. So we've got this possibility there and this possibility there. So for part B, okay, I'll just do part B here. So the probability that last letter is A. Okay, is equal to, now how many possibilities are there? We've got 6 possibilities, of which there are 2 that are of interest, okay, the favoured outcomes, and that's equal to 1/3.